Hi everyone, in this video I would like to talk about problem number 3 on PUMaC, on number theory round. This is going to be in the division B, so let's just go over this problem. Find the sum of all prime numbers p such that p divides. We have p squared plus p plus 20 to the power of p squared plus p plus 2. And we also have 4 times p squared plus p plus 22 to the power of p squared minus p plus 4. And I need to find out all sum of prime numbers p such that this is divided out by p, right? So I would say in order to use mod p, we'd better use Fermat's little theorem, right? So according to Fermat's little theorem, anything that is relatively prime to p is going to have p minus 1 to the power, the power of p minus 1. It results in 1 mod p, right? So I would say anything a to the power p minus 1 is going to be 1 mod p for sure. And of course, we need to make sure that a and p are relatively prime, right? So what do you know about this? P squared plus p. That's a multiple of p. And you can check that this is also a multiple of p as well. So in other words, I think I know that these are any expressions that you see here, it's just going to be relatively prime to, the given expressions. And all I need to check is whether this is divided out by p minus 1. So I would say we got to divide that p squared plus p plus 2 by p minus 1. Right? So let's check this out. So after, using this Fermat's little theorem, we kind of checked that p squared plus p plus 2 divided out by p minus 1. Well, we get p out there, so p squared minus p, and we can subtract it out. We get 2p plus 2, so we get plus 2. So we have 2p minus 2, and if we subtract it out, we get 4. So I would say the whole expression, the left side expression, will be just p squared plus p plus 20 to the power of 4, right, in mod p. And I would say we got to do the same thing for this one too. And let's just try to move this, place this out here, and perform another division. So p squared plus p, p minus, right? So p minus p plus 4, divided out by p minus 1. So in fact, well, we get p squared minus p, and dot, 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 out of 4. So I think that we kind of see how things are working out. So the given original expressions that we saw here is in fact going to be p squared plus p plus 20 to the power of 4. And all I need to do is just to add it up by 4 times p squared plus p plus 22 to the power of 4. And I think that we need to find this in mod p, right? So let's just try to move this, place this right here. Let's try to erase this, okay? And we have something about p, like some expressions of p plus 20. So I would say 20 to the power of 4 plus 4 times 22 to the power of 4 in mod p. All right, so let's just try to see how this gets changed. So I would say probably we can use some, some like algebraic tools. And according to some algebraic tools that we know, probably it's going to be better off if we just add some expressions. 4 times 20 squared times 22 squared plus 4 times 22 to the power of 4 minus 4 times 20 squared times 22 squared. It looks like Sophie-Germain, right? So we have 20 squared plus 2 times 22 squared minus, and of course, there's a square expressions, and we get 2 times 20 times 22 squared. Okay, so we're almost done. All we need to do is just to compute this value. So we have 20 squared minus 2 times 20 times 22 plus 2 times 22 squared. And of course, if I multiply this out by 20 squared plus 2 times 20 times 22 plus 2 times 22 squared, well, guess what? That turns out to be 400 And of course, we just have to multiply this out by 880, I would say, because that's 440. And we are adding up with 2 times 484. And of course, there's a 400 plus, it should be 880 plus 2 times 484. Okay. All right. Whew, this is hard. We have negative 480, and I need to add it up by 2 times 484. What's that? I don't know. I'm really bad at arithmetic. So I got to multiply this out by 8 and 6 out there and 9. So we get 968. And we have 1280 plus 968. Okay. So I would say we end up getting 968 minus 480. So 968 minus 480. We know that these are 8, and you can cross it out 8, an extra 8, and 4. So 488. 488 times, well, what is this? 1280 plus 968. If you add it up, you get 8 and 4 and 2 and 2. So 2248. So we kind of noticed that these are 2 times, or actually we can make it into 4 times. 122. And if you multiply this out, what is this? That becomes 2 times 1124. And you can still break this apart into 2 times 562. And that becomes 2 times 281. And 281, if you try out using like the square roots of 281, well, we'd better think about like like a prime number that is smaller than 17, and none of them works out. So we have lots of powers of 2. So 2 to the power of 3 times 281. And we have 2 to the power of 2 and 2 times 61 times 2 cubed and 281. So we have 2 to the power of 6 times 61 times 281. And what were we really getting? I think we're getting for the sum of all primes. So the sum of all primes that actually works out will be 2, 61, and 281, because prime P divides everything out here. So I would say eventually we get P value could be either 2 or 61 or 281. So let's just try to add up all these sum. So sum becomes 63 plus 281. And I would say the answer becomes 344. And yes,